What if the most lethal biological weapon on Earth became entirely useless because your lunch decided to simply change the physical locks on its own cells? We are taught from a very young age that apex predators hold an absolute monopoly over life and death. The conventional wisdom says that if you possess 3-inch canine teeth, a muscle mass of 400 pounds, and jaws capable of snapping solid bone like dry kindling, you win by default. But nature is not a Hollywood movie, and it certainly does not respect your high-tier predatory status. Out here, a slow, clumsy rodent can turn a lion's forward charge into a slow-motion suicide mission, while a tiny mammalian tank can shrug off a lethal dose of neurotoxic cobra venom that would put an adult elephant into a permanent grave. Today, we are tearing up the old rulebook and opening up a premium, hand-drawn tactical spreadsheet to audit a 300-million-year war where absolute offense meets unbreakable, rule-bending defense. Welcome to Fauna Ledger. I am your narrator, Jonathan, and right down there on our interactive paper sketchbook is the Ledger Explorer, a brave stick figure who is currently trying to look professional while standing next to a highly volatile biological entity. Today, we are executing a comprehensive, deep dive forensic audit of nature's ultimate defensive mechanics. We are examining 3 separate evolutionary masterminds that looked at the terrifying weapons of apex predators and said, "No, I don't think I will participate in your food chain today." We will break down the structural, ballistics-grade defensive loadout of the crested porcupine, map the chronological journey of the honey badger from a helpless pup to a molecularly immune beast, explore the cellular hacking that bounces lethal nerve toxins off like a sci-fi force field, and finish by testing the medieval plate armor of the pangolin against the absolute crushing forces of large cats. Let's flip the page, check the metrics, and watch our little stick figure friend get into some serious physical trouble. Let's kick off this audit with our first block, the size matchup. The Ledger Explorer is currently stepping onto the page, armed with nothing but a standard cheap plastic school ruler, attempting to measure a fully grown crested porcupine, Hystrix cristata. Let's watch as he gets a bit too close to the rear end of the drawn animal. Oh, there it is. A swift backward shuffle from the porcupine, and our stick figure friend has just pricked his hand-drawn fingers on a quill tip. He is currently jumping around the edge of the page, holding his pixelated thumb.
Man, are you okay?
Let's leave him to suffer for a second while we look at the actual data. When you look at a crested porcupine from a distance, it looks like a slow, fat, waddling rodent that weighs anywhere from 15 to 30 kilograms. It shares its African and European habitats with leopards, hyenas, and lions, animals that outclass it in terms of raw muscle, speed, and jaw pressure by several 100%. It looks completely disproportionate, a total mismatch on paper. But let's look behind the sketch. The porcupine has modified its devolutionary budget by transforming its ordinary hair into a complex multi-layered defense network consisting of roughly 30,000 individual keratin quills. Let's bring up our hand-drawn chalkboard overlay to look at the structural distribution. This loadout acts exactly like a modern biological equivalent of high-density medieval chainmail. Along its neck and shoulders, the porcupine carries long, flexible, thin quills that can stretch up to 35 centimeters. These are defensive decoys. When a predator approaches, the porcupine flares them out, doubling its visual volume to make an attacking cat rethink its life choices. But the real tactical horror is found on its lower back and tail. These are the short, thick, rigid quills, and they are designed for pure ballistics. Let's zoom in on a slow-motion breakdown of a predator biting into this area. When a lion bites a porcupine, it expects soft meat, but instead, its gums encounter a wall of sharp keratin needles. Here is the retention hook that every predator learns the hard way. The tip of a porcupine quill is covered in thousands of backward-facing, microscopic barbs. When the quill enters the predator's flesh, these barbs fold flat, requiring very little force to slide in deep. But the moment the predator pulls back, those microbarbs flare outward like tiny anchors, locking the quill firmly inside the flesh. The connection between the quill and the porcupine's skin is incredibly weak. It takes almost no force to detach the quill from the rodent, but it takes an immense, agonizing amount of pull to get it out of the predator. Let's look at the on-screen bar graph comparing quill length versus predator jaw clearance. The quills are perfectly sized to bypass the lips and penetrate straight into the deep muscle tissue of a lion's face. Once planted, the physics gets even worse. Because of the orientation of the microbarbs, every time the injured predator blinks, breathes, or moves its facial muscles to chew, the shifting muscle fibers push against the barbs, forcing the quill to travel forward, burrowing deeper into the body at a rate of several millimeters a day. These quills can travel through jaws, pierce eyes, or end up puncturing the jugular vein weeks after the porcupine has walked away. It is an active kinetic minefield that uses the predator's own daily movements to destroy it from the inside out. I remember analyzing a field report where an entire pride of lions was forced to avoid hunting for months because two young males had their muzzles completely filled with these self-burrowing daggers. They couldn't open their mouths wide enough to secure a suffocating throat bite on a buffalo without driving the quills directly into their own palates. This isn't just about pain. It's about shifting the energetic balance of a hunt so heavily against the predator that the mere sight of a porcupine causes an experienced leopard to turn around and hunt something else. The Ledger Explorer is currently trying to extract a stray quill from his foot using a pair of oversized hand-drawn tweezers. Let's let him struggle with that while we move our analysis over to the next sheet of our survival ledger. The numbers do not lie, and right now, the porcupine is sitting on a massive profit margin of pure defensive efficiency. If you want to keep auditing these mind-blowing animal mechanics without the dry classroom lectures, hit that subscribe button right now and join the Fauna Ledger crew. Now, let's turn the page to our second major block, the timeline, egg to apex, or in this specific case, from birth to survivor. Let's sketch out a newborn honey badger pup, Mellivora capensis. Look at this pathetic little thing down here. It is born completely blind, totally hairless, and weighs a meager 130 grams. That is roughly the weight of a single medium-sized apple. It has an offensive rating of 0 and a defensive score that is honestly embarrassing. If you left this pup alone on the savannah for 5 minutes, a passing jackal or a large raptor would end its evolutionary timeline without a second thought. Let's bring up our chronological progress bar, tracking the day 1 to year 2 survival metrics. During the first 8 long months of its life, the honey badger pup is entirely dependent on its mother. It grows at a remarkably slow pace, but this extended childhood is actually a highly specialized tactical training boot camp. Around month 4, the mother begins taking the pup on foraging raids. They don't start by fighting lions or cobras. They start small. The young badger is introduced to the world of toxic invertebrates. It learns to dig up scorpions, centipedes, and highly venomous spiders. When a scorpion stings the young badger on its soft nose, It hurts terribly, but it doesn't kill it. This minor exposure acts like a natural vaccination process, allowing the young badger's immune system to build up tolerance, while its brain learns the specific physical maneuvers required to pin a venomous target down by the head without getting stung. By month 12, the badger has grown from a fragile, hairless newborn into a 10-kilogram block of pure, low-slung muscle covered in a coarse black and white coat. It has entered its sub-adult phase, and its defensive spreadsheet is starting to look incredibly strong. Now let's jump forward to the definitive trial of fire in year 2. The adult honey badger is now fully independent and wandering through the dry brush when it crosses paths with a mature 3-meter-long king cobra. This is the moment where the timeline hits its peak high-stakes tension. The cobra rears up, spreads its hood, and prepares to deploy its primary win condition. A chemical weapon that can melt tissue and stop a mammalian heart in minutes. A normal animal would run, but the honey badger has completed its training. It steps forward, lowers its head, and enters a brutal, fast-paced biological duel where a single mechanical mistake means a direct injection of lethal neurotoxins. Watch the ledger explorer down there trying to film this interaction. He set up his tiny drawn tripod way too close, and the cobra just lashed out, striking his camera lens with a wet, heavy thud. He is now hiding behind our logo, shaking like a leaf. Let's look at what happens over the next 10 minutes of this encounter. The honey badger does not attack with reckless abandon. It uses a highly calculated circular movement pattern designed to exhaust the snake. The cobra strikes repeatedly, its fangs moving at speeds exceeding 3 meters per second. The badger relies on its dense bone structure and a remarkably low center of gravity to slip underneath the snake's strike zone. Eventually, the badger finds its opening, lunging forward with jaws that can exert up to 400 newtons of pressure, aiming directly for the base of the cobra's skull. It bites down, crushing the neurological control center of the reptile. But before the snake dies, it manages to land a desperate, full-depth bite right into the badger's face, emptying its entire venom gland into the mammal's bloodstream. The badger finishes its meal, chews through the snake's head, and then, suddenly, the chemical tax comes due. The badger's movements slow down. Its eyes glaze over. It collapses into the dirt, completely motionless, entering what appears to be a terminal coma. If you ran a blood panel on the animal right now, you would see numbers that signify certain death for 99% of all land mammals. Yet, its system is busy running a background program that has been optimized over millions of generations. It burns through immense metabolic resources while unconscious, neutralizing the proteins before they can cause permanent cellular collapse. It is a calculated gamble, a temporary bankruptcy of consciousness paid in exchange for an incredibly dense source of protein and fat that no other carnivore on the savanna can access without dying. Are you rooting for the cobra's chemical warfare or the badger's raw grit? Let me know your tactical analysis in the comments section below. This brings us right into our third block, weird weapons and powers. To demonstrate the insane biochemical engineering at play here, the Ledger Explorer has volunteered to step into our simulated molecular combat arena. Look at him down there, wearing a tiny lab coat and holding a giant cardboard model of an alpha neurotoxin molecule. Let's watch as a drawn cobra fangs him directly in his stick figure shin. Oh boy, his stick legs are currently vibrating violently, His eyes have turned into little pixelated X marks, and he has collapsed face first onto the paper grid. Let's let him reboot his software while we explain the actual cellular biology behind the honey badger's internal cheat codes. In almost every mammal on Earth, your brain controls your muscles via a neurotransmitter called acetylcholine. This chemical travels through your nervous system and plugs into specific docking bays called nicotinic acetylcholine receptors on your muscle cells. It works exactly like a classic lock and key mechanism. When the key plugs in, your muscles contract, allowing you to move, blink, and expand your chest to draw in oxygen. A cobra's venom is packed with alpha neurotoxins, which are essentially molecular saboteurs. They are shaped exactly like the correct key, but their goal is to jam the lock permanently. They flood the receptors, binding to them with an iron grip and blocking the real acetylcholine from getting through. The lines of communication are instantly severed. The brain commands the lungs to breathe, but the lungs cannot hear the signal. The victim dies of rapid, terrifying respiratory paralysis. It literally suffocates while fully conscious. But the honey badger managed to execute the ultimate molecular hack. Over millions of years of fighting venomous reptiles, its DNA mutated, slightly altering the specific amino acid sequence that constructs the shape of those acetylcholine receptors. Let's bring up our interactive lock and key animation to show the failure to bind. The docking port on a honey badger's cellular membrane has a tiny structural bump that does not exist in other mammals. When the cobra's neurotoxin arrives in the bloodstream and tries to plug into the slot, it physically cannot fit the lock. The toxin molecule simply bounces off the cell wall like a tennis ball hitting a concrete force field, leaving the nervous system completely free to keep sending signals to the lungs. But biochemical hacking is only half the badger's power loadout. Let's check out the physics of its detached skin. A honey badger's skin is incredibly thick, 6 millimeters of tough, fibrous hide around its neck, which is thicker than the skin of a large wolf. But the real engineering genius is that this hide is entirely loose, completely detached from the underlying muscle and connective tissue layers. It fits the badger like an incredibly oversized, heavy-duty leather trench coat. If an apex predator, like a leopard, pounces on the badger and bites down on its neck, it thinks it has secured a lethal throat crush hold. But inside that loose sleeve of skin, the honey badger can literally rotate its entire skeletal frame 180 degrees. While the leopard is busy chewing on the rubbery, sliding outer hide, menacing, the badger turns completely around inside its own skin and uses its massive claws and razor-sharp teeth to rip directly into the leopard's eyes and nose. It turns a definitive predatory win condition into a painful, bloody escape opportunity. I've spent hours reviewing footage of these interactions, and it's always the same story. The big cat holds on, thinking it has won, while the badger is actively mutilating the cat's face from inside its own skin pocket. It's a double-layered defense budget, an impenetrable outer coat that moves independently of the vital organs, paired with an internal cellular shield that protects the nervous system from chemical assassination. The Ledger Explorer is currently trying to fix his lab coat with some hand-drawn duct tape. Let's flip the ledger over to our final entry to see what happens when an animal decides to skip the biochemistry entirely and invest its entire capital into pure, unadulterated structural plating. If you love seeing complex biochemistry turned into a gamified battle map, leave a like on this video to keep our ledger running smoothly. Let's turn to our final block, the human-wildlife clash. To complete our defensive trinity, we need to introduce the absolute king of heavy plate armor, the pangolin, specifically the giant pangolin, Smutsia gigantea. Look at this spectacular creature down on the ledger sheet. It has 0 teeth, moves at a glacial pace, eats nothing but ants, and possesses absolutely no offensive capability. Yet, it walks through the African forest like an absolute tank. Why? Because its entire body is covered in large, overlapping scales made of highly compacted keratin. These scales are so dense that they make up to 20% of the animal's total body mass. Let's watch the ledger explorer try to crack a rolled-up pangolin with a tiny drawn sledgehammer. He swings. The hammer hits the scale, bounces straight back, and hits him directly in his stick-figure forehead, flattening him like a pancake. That is a very accurate representation of the physics of a pangolin sphere. When a lion or a leopard corners a pangolin, the animal does not run. It rolls itself into a tight, seamless ball, tucking its soft belly and unprotected head deep inside the center, and wraps its muscular, scale-covered tail around the exterior. Now let's look at our pressure gauge needle pinning at maximum force before cracking. A large wildcat can exert a jaw pressure of well over 1,000 newtons. It will bite down on the pangolin ball, trying to find a weak point or a seam. But the geometric design of the overlapping scales distributes that crushing force evenly across the entire spherical surface, preventing any single plate from breaking under the stress. Furthermore, the outer edges of the scales are sharp as razor blades. As the lion tries to chew on the sphere, the scales cut into its sensitive gums and lips, forcing the apex predator to give up out of pure frustration and pain, leaving the pangolin entirely uninjured inside its portable fortress. But here is the tragic, heartbreaking irony of this 300-million-year war. The exact same evolutionary armor that makes the pangolin completely invincible against 1,000 newtons of lion jaw pressure makes it completely, utterly defenseless against humans. When a human poacher approaches a pangolin, the animal doesn't flee. It rolls into its perfect little ball and stays completely still.
Curvature check.
The human doesn't need teeth, claws, or venom. He doesn't need to fight the armor. He just bends down, picks up the 10-kilogram ball, and drops it into a burlap sack. Because of the absurd myths of traditional medicine, which claim that these keratin scales can cure ailments, despite being made of the exact same boring material as human fingernails, the pangolin has become the most heavily trafficked mammal on the planet. Millions of these defensive masterminds have been dragged out of their ecosystems, pushing them to the absolute brink of extinction. This is a massive failure in our global biodiversity spreadsheet. We have a moral responsibility to use our intelligence not to exploit these ancient evolutionary defense codes, but to protect them. We must understand that when we wipe out a specialized survivor like the pangolin, we are just losing an animal. We are erasing millions of years of irreplaceable biological engineering from the Earth's collective ledger forever. We must dismantle the illegal poaching networks, support local conservation initiatives, and ensure that creatures like the pangolin can continue to roll up and baffle lions for another 100 million years. The Ledger Explorer has finally unstuck himself from the floor and is holding up a tiny hand-drawn recycling sign. Let's clean up our workspace, finalize the data entry, and see how the final balance sheet looks for our 3 defensive champions.
Data is all here.
Check out the video on your screen right now
The
to see
audit.
how other unique creatures optimize their survival metrics, and we will see you in the next forensic audit of the Fauna Ledger. Survival in the natural world is never a simple equation of who has the biggest muscles or the loudest roar. It is an ongoing, cold-blooded calculation of energy efficiency, physics, and molecular engineering. The crested porcupine, the honey badger, and the pangolin are
Survival
living proof
champions.
that you do not
Scene
need to be
12,
the
a
king of the
maze
jungle
defensive
to
formation.
win the game of life.
Rough animator.
You just need to make the cost of killing you so ridiculously high that the smart money simply goes somewhere else. Thank you for opening the ledger and auditing the numbers with us today on Fauna Ledger. Keep your eyes sharp, respect the ancient survival codes of the wild, and, as always, keep exploring.